Good morning, Doctor.
Good morning. Okay, before I start, last class, kita bincang pasal apa? Can anyone help me?
Six Sigma.
Pasal apa? Six Sigma.
Six Sigma.
Okay.
And
Alright.
it's about this one, DMAIC and a bit of DMADV.
Alright.
Not mistaken.
Okay, so I have introduced to you in general what is Six Sigma, right? Okay.
Yeah.
Alright, so today let me continue with the same topic on Six Sigma in more detail. Okay, let me see how many online now. So we have 42. Okay, we're still waiting for at least 10 more students. Okay, so we continue. Please make sure you scan your attendance. I already put in Telegram.
Doctor, Doctor.
Echo.
Yes.
Kenapa ada echo Saya dengar okey je. Orang echo juga ke?
Yes, Doctor.
Is it echo? Everyone have echo problem? Hello?
No, Doctor.
You are okay? No echo. I don't hear any echo because I'm just in my office now. Should be okay, I think.
Okay, Doctor.
It's okay now. All right. Okay. So DMAIC. Okay. DMIC is can we call it a problem-solving process lah? It's a problem-solving process. This is under the title of Six Sigma. Six Sigma. Okay. So as I mentioned in last class, knowledge on Six Sigma is very important. When you are talking about quality, okay, we are talking about quality. Okay, one of the skill that is being they call it needed by organization is they call it knowledge on Six Sigma. Okay, so Six Sigma here we are not only referring to this number of 6 multiplied by sigma. Okay, so Six Sigma here we are referring to the problem solving process. Okay, problem solving process. So when we say Six Sigma, we are referring to two ways of referring this. You can refer this as statistical value, Six Sigma, or you can look it as a method of problem solving. Okay, philosophically, it is a problem solving process. Okay, so problem solving process. When we say Six Sigma, we are referring problem solving process, or we are referring to the numbers. Okay, what is 6 multiplied by sigma? Sigma here is just standard deviation. This is just standard deviation from the normal distribution. We know that sigma is standard deviation of distribution. Okay, if you have a histogram, remember I asked you earlier in the discourse to plot the weight or height. So when you plot, you got histogram. So you want to describe this distribution, we can describe it in terms of mean, okay, the mean, or we estimate the average for the mean, okay, or you can describe in terms of how is the value dispersion, we call it dispersion, how is dispersed or surrounding the mean. Okay, this is a sigma. Okay, sigma. If we take sample, the mean here normally we put it x bar, or if we take a mean of a mean, it will be x double bar. So if you take sample, this will be s okay. So what we refer here Six Sigma, assuming this is a population. Okay, this is for population. In statistics, you have population, you have sample. Okay. So So when we say 6 sigma, we are referring to statistical value, or we are referring to problem solving process. Okay, I put it in red color here. Okay, if we are referring it as a problem solving process, so it is DMIAC. Okay, this is for solving operational problem. Okay, if we design, we have MDA. What is the other one? We have DMIC. Last class I mentioned that. DMAIC. For the design, what do we have?
DMADV.
DMADV. Okay. So this 6 sigma also
ADV.
DM again. Hello. Is this correct?
Yes.
Yes, Doctor.
Yes, Doctor.
All right. So this is for design. So sometimes people call it design for 6 sigma. Okay. So even this concept of 6 sigma, you can put it in design. Okay. Design for 6 sigma. Okay, but this one, the MIC, is problem solving. Normally, this is solving operational problem. When we operate a system where we involve with, we are running the operation. Okay, we are running any activities. We have problem that we can solve using DMAIC. Okay, so D, what is D again?
Define.
Define and
Measure.
Define, measure. A,
Analysis.
Analyze.
Analyze.
Yeah, analyze. Okay.
Improve.
Improve.
Control.
And
C.
control. Control. So, okay, every step of this, there are tools and techniques that we can use. Okay, there are tools and techniques that we can use. Some of the tools you have learned. Okay, like when we say basic SPC tools. Okay, we have fishbone diagram, we have Pareto, we have control chart, you have process chart, can be used, okay, at the relevant step, okay, from either D or M or I or IC. Okay, so we are using those for problem solving. So I also did mention there is another problem solving step or process, PDCA. Okay, PDCA. Also, this is commonly used also. Okay, plan, do, check, act. Okay, PDCA. This is a common also. When we say PDCA, meaning that plan, do, check, act. So this is a step for problem solving. But DMIC is more detailed. More detailed. So let's move on. See this. Okay. Okay, you can also refer to your textbook. Some of these notes are coming from your books. So e-books are already put in your e-learning. Please have a look into it. Okay, the MIC. Okay, I have not explained this, right? This slide already in e-learning or not? Can someone respond to me?
Not yet.
Not yet, okay. So the slide is not yet, and also I have not put in e-learning. Is it correct?
Yes.
Okay, so pay attention first. Okay, later on I will put it, but it's better for you also to have some your personal notes. Don't just listen without putting any, at least keywords for you to easy for you to revise again. Okay, if you just listen without any note, okay, we have a short memory. Yeah, if you don't record anything or if you don't what do you call this, jot down any keywords. Okay, so the definition, as I mentioned, that 6 sigma can be in terms of measurement, okay, which is referring to 3.4 defects per million opportunity. So when we have 6 sigma quality level, so actually the company is producing only 3.4 defects. Okay, maknanya yang reject is only 3.4. If we produce 1 million, okay, if we produce 1 million, we only have 3.4. So rarely, okay, in any organization we achieve 1 million unless we are producing a small component. We may produce 1 million. Okay, so it means that we almost perfect. Okay, almost perfect. 1 million, only 3.4 unit rejects. Okay, so if we say Six Sigma is a methodology, it is problem solving. Okay, structured problem solving. So meaning that it is systematic. We have step by step. If we say it is a philosophy, Six Sigma mean customer focus. Okay, our culture is to make the customer happy. Okay, so there are many benefits of it. Okay, this is easy. You can read on your own. Benefit. So it is helping to have rapid breakthrough performance, continuous improvement, and so on. And Six Sigma are related to this concept. This concept, zero defect. Zero defect. Why zero defect? Because when we have Six Sigma quality, let's say you have here is upper specification limit, and you have here is lower specification limit. Okay, so your variability is somewhere here, almost on target. Okay, you have very slim. Okay, so if there is any shift, okay, any shifting in the process, we are still okay. Let's say this is shifted to this side. Okay, so the mean is shifted. Still okay. We are still within specification limit. Okay, within specification limit. Specification is very far from the process variation. So we can say it is zero defect. Defect happen if it is outside. Okay, outside the specification limit. Okay, so even if shifted to the left side, we are still okay. So this is the dream of many companies to achieve this zero defect. When we have this zero defect, we don't have to employ operator for inspection. Okay, we can have safe inspection cost. Inspection cost, we save money on that, and our production also will move faster. Okay, so because everything we produce, we are guaranteed that it is of good quality. Okay, so but how to achieve this? Yeah, this is a lot of effort needed that require the step that DMAIC. So statistically, we can show that when we have Six Sigma, this is what I mean zero defect. There is no product outside. But if our operation is not Six Sigma, let's say we have a lower specification like this, upper specification like this. Okay. If we have something like this, okay, so this is dangerous. Even we have a small shift. Okay, even a small shift. Let's say this, the center is shifted a little bit. Okay, so you already have some item out. Okay, some item outside specification limit by just a small shift in here. Okay, a small shift already generate some defects. Okay, some defects already produced. Okay, so our job now is how to make it more slim compared to this one. Okay, so that's the concept of it. And then okay, so the concept of Six Sigma is variation reduction. Okay, we want to reduce variation. We want to reduce this variation so that it will become slim like this. Okay, we want it to have a stable operations. Okay, operation which is not influenced by assignable cost. Assignable cost is a cost that create why it is shifted. Okay, when the center shifted, okay, many product will be outside, especially when we are operating. In this case, we are operating, maybe this is plus 3 sigma, and this is another 3 sigma. But in this case, the 3 sigma is here. This is 3 sigma. But the sigma here is smaller value. Okay, smaller value of sigma. That's why you got it less. The band is smaller. Okay, so but when we have let's say 6 sigma, okay, your 6 sigma is, you are having up to 6 sigma up to here. Okay, very far, 6 sigma. In terms of physical distance, it may be about the same. Okay, but the sigma here is lower sigma, lower values. All right, so here we can also have this, I mentioned earlier, the MADV. Yeah? This is designed for 6 sigma. Okay, so these are key concepts related to 6 sigma. Okay, so we are clear now on this. Okay, so CP equal to 2. Okay, why is CP is equal to 2? Okay, if we have here is 6 sigma. Here is 6. Okay, referring to this one, referring to the yellow color. Okay, so if up to here is 3, this also 3. So what we do is CP is actually the tolerance. CP is capability index, capability index, divided by process variation. Okay, so CP is process capability index. We will use this quite often, process capability index. Okay, so what is the tolerance? Tolerance is upper spec limit minus lower spec limit divided by process variation. Process variation is known as 6 multiplied by sigma. Don't confuse, this is 6 sigma, here is basically 3 plus 3. Okay, so another way to put it is upper spec limit divided by, you have it, the distance here between minus 3, this is minus 3, this is plus 3, plus 3. So basically, so it is, the distance is 6 sigma. Okay, so this is 6 sigma there. Okay, I don't need to write this again. I think it's clear there. Any question up to that point? So here you have 12 divided by 6. So that's why you get 2. Okay, so this is why you get 2 here. Okay, so on this one, okay, this is 1.33. This is happening at, this is, okay, in this color. So 1.33. So if we are having, this is shifted. Okay, this is if let's say this is shifted a bit, if we are shifted, so this one will be outside. Okay, if I can show you, okay, it looks very, maybe the diagram is not so clear here, but anyway, what it's saying is if let's say there is a shifted, 1.5 shifted, okay, so you will have some will be outside. Okay, so in that case, we have 1.33. Why 1.33? This is CP equal. Okay, we have 8 sigma divided by 6 sigma. Of course, the sigma value will be different. Okay, if you see here, the range here is, okay, the range here is, actually this is 3. And this is 3. Okay, of course, the sigma is not the same, or the value is not the same. Okay, so up to this point, it will be 4 sigma if we measure it to the middle. Okay, so that's why we have 8. So we're going to have 1.33. This is where many organizations, many manufacturing are, okay, only at this point, 1.33. Okay, as I mentioned earlier, if you want to set a tolerance, we put it 8, or we put it 4 sigma, 4 sigma to the left, 4 sigma to the right. And then 6 sigma is process variation. Okay, this process variation is known as 6 sigma, which is the difference between, okay, maybe I can write it here, that process variation, if we're referring to control chart, okay, we will learn later, control chart, process variation, okay, we say it is 6 sigma. Okay, this is also same as upper control limit minus lower control limit. In control chart, don't confuse control limit and specification limit. Okay, up to this point, is it clear? Hello?
Clear, sir.
All right. Okay, let me move. Okay, I think this one already explained. Okay, the range between plus minus 1 is 68,
Yes, sir.
plus minus 2 is 95, plus minus 3 is 99.73. Already explained before, right? Okay, let me explain about the shifting. Okay, so if you are having the 6 sigma quality level, this is specification limit, this is lower, this is upper. So we are having ideally this is the, yeah, I don't get the color here, right? Okay. Okay, we have this, we have this curve. Okay, we have this curve. So what is saying, okay, if we have ideal situation, so actually we are having 2 defects per billion. Okay, okay, actually you have 2 defects . Okay, 2 defects per billion. Okay, billion. What is billion? How many million? We have 1 billion. Hello?
10 to power of 9.
10 to the power of 9. Okay, so when we are shifting, let's see here, the center here shifted. Okay, okay, the center here is shifted by how much? 1.5. 1.5 sigma shifted. Okay, shifted. So what we have is this curve, the green curve. and then you will have a small portion here will be outside. Okay, this is what we have. Probability of to be outside is 0.00000034. Okay, meaning that 3.4 defect per million opportunity. So this is what we say 3.4 defects per million. Okay, so the value that we mentioned earlier is considering there is a shifted, already shifted by 1.5. 1.5 shift is considered is in the category of big shift, big shift. Shifting here meaning that if you setting your process at this point, after some time, because of wear and tear or because vibration, the centering jump to a new location. If it is jumped by 1.5, we're going to have 3.4 defects per million instead of 2 defects per billion. Okay, so ideally, if there is no shifting, okay, if there is no shifting, 6 sigma mean 2 defects per billion. But there is, when there is a shift of 1.5 sigma, the result will be 3.4 per million. Why? Some portion will be outside here. Even this is very small number. Okay, you need to produce 1 million, only 3.4. So roughly we can say this is like a 0 defects. Okay, it's very close to 0. 0 defects, no defects, everything perfect. So when everything is perfect, so you don't have to have inspector. You are guaranteed everything produced is good. After production, can directly do packaging and send to customer. Okay, we save a lot of cost there. Okay, the concept of shifting 1.5 in 6 sigma, is it clear? Any question?
Clear, Doctor.
Right. Okay, this is a comparison. This is a table comparison. If you are 3 plus minus 3, okay, if you are producing 1 million, you're going to have 2,700 defects, okay, per million, okay, 2,700. But if you produce at 6 sigma, you only to produce okay, this is okay, this is per billion, 2 defects per billion, 0.0002, 10 to the power of 9, right? To the power of 9. So this is basically 2 per billion. Okay. This is considering no shifting, 0.002, okay, per part per million. Okay, not even 1 unit if you produce. But when there is shifting, okay, we're going to have this 3.4. This is considering the center of center by 1.5 sigma. You're going to have this. Okay, so plus minus 3, even we have more. Okay, we have more, not 2,700, but now 66,810 will be non-conformance. So you can see the effect is very big. So we have plus minus 6 sigma, we only have 3.4 part per million. Okay, when it is off-centered by 1 point, plus minus left to or right, left, shifting to the left 1.5 or shifting to the right 1.5. But if there is no shift, they are centered. Here is 2,700. Okay, no shifting, and 0.002 per million, or another word you can say 2 over 1 billion. Okay. All right. So that is statistical explanation of 6 sigma. Okay, 6 sigma as methodology. Okay, so it's an overall methodology that provides standardized problem-solving tools. It is standard methods. Okay, standard method, 6 sigma. as I mentioned to you earlier, is Six Sigma. Some people go and have professional courses on Six Sigma. Okay, you can qualify as certified black belt Six Sigma, or green belt, or yellow belt. You know, these are you are learning about the same thing, but you need to do some projects in order to qualify to be certified. Okay. Okay, so in this step, the MIC, okay, we start with define, measure, analyze, improve, and control. Okay, so it's a step. You can say it is like a roadmap. Okay, roadmap. When we have a problem, we have to define, okay, what is important for us to solve. Okay, define the opportunity for improvement. Okay, after we know that we have clarified the problem, we need to measure the problem. Okay, we need to understand the problem by measuring the current status. Okay, how are we doing? So in order to understand where we are, we need to measure. Okay, and then we analyze. Okay, after having the data, we need to analyze what actually went wrong. Is it due to equipment? Is it due to material? Is it due to process, or what? So analysis is the third step. And then we improve after that. Okay, do the improvement. What need to be done? Okay, so we may use some statistical techniques, okay, to assist us in performing the improvement activity, like doing design of experiment and so on. After that, we implement, and we have to control the performance of the improved process. Okay, how can we guarantee the performance will be maintained? Okay, so this is a systematic approach. So what are the tools? Okay, this is, they call it tool gate. The MIC process tool gate, meaning that from one step to another step. Okay, what are the checkpoints? Like you going to a place, there is a gate to control you from entering the place. So this just guide us what are the things that we need to do. Okay, so in defined stage, okay, we have to know or establish what we call it a project charter. Okay, project charter and so on. Okay. Okay, in the defined stage. Okay, in defined stage. Okay, we need to define what is the problem. Okay, how do we select the problem to be solved? And knowledge and project management will be important when we are using this project management, DMIC. Okay, so because this is treated as a project. Okay, when we have problem, we solve it as a project. Okay, so it require, in defined stage, it require project selection. Okay, which problem that we want to solve. Okay, we have to have some method to evaluate the priority for project to be given priority. Okay, so the selection will be based on critical to customer. Is it critical to customer or not? This particular problem. Okay, is it critical to the business? Okay, is it important to the customer focus? Okay, so meaning that the customer is concerned about it, customer focus. So we try to satisfy the customer. Okay, so in project selection, we have to take care whether it's addressing the customer needs or not. Okay, so how significant it is, the project that we said. Project here is referring to problems that we would like to tackle in using Six Sigma method. Okay, so what we do in after we select that is we formally go to the define step, which is the first stage. The first stage. So we need to create what we call it project charter. Okay, project charter. Project charter, this is like a project proposal lah. okay, like project proposal, project charter. So this will be the central main document for reference, project charter. Okay, like when you want to do a project, you have project proposal. So you will put there what is your objective, how you define the problem, and so on. So in the project charter, you need to have what is critical issues that concern with customer, what is the goal, what is the objective, who are responsible, okay, the team role, okay, the scope of the projects, and okay, very important here, we call it SIPOC. Okay, we need to come up with mapping, what we call it SIPOC, SIPOC. So this is stand for supplier, input, process, output, and customer. Okay, so we need to do that mapping, and then we have to have the baseline for us to measure, okay, whether is there any improvement or not. Baseline is like reference point for us to compare before and after. We develop mapping for the current process. Okay, so this example of project charter. In the project charter, you should have business case, which is the problem, the goal statement, the project plan, okay, when it started, when it's ending, and the statement of the problem or opportunity. What is the problem there? Okay. For example, in this case, we have opportunity exists to close the gap between our customer expectation and our actual performance by reducing cycle time. So this is like problem statement. And you are going to have a scope and who are responsible in the team. Okay. So this is a simplified version of project charter where we produce it during define stage. Okay. Remember, define stage, we are defining the problem. We are defining the projects. What is the result of define stage? Is a project charter. This is another example of project charter. Okay, you have business case. Again, you have a statement, you have project plan. Okay, so maybe the wording here is slightly different, but anyway, the core element is there. Okay, this is another example. Okay, project charter. And of course, you need to understand the customer because it's customer focused. So here I put it a little bit more explanation about customer. But anyway, we have discussed about Kano last time. The Kano, this one, you can use as reference. Okay, this is a defined stage. Okay, what are the techniques? Okay, what are the techniques that should be used in defined stage? Okay, any of these that you have seen before, any of these tools that you have seen before that can be used in defined stage? Arun, okay, from the list here, which one that you have seen?
Maybe process mapping.
Okay, process mapping. Okay, process mapping. Before this, we learn what in process related to process mapping? What method?
Flowchart.
Okay, okay, flowchart. You have seen the flowchart before, So we can use this flowchart in defined stage. Okay, flowchart. We can map the process. Okay, summarize that in terms of process mapping. Okay, you can also use the CPOC. Okay, the one that I just mentioned before this. So this CPOC is normally is known as techniques for the Six Sigma method, where we are mapping the supplier, the input, the process, the output, and customer. In flowchart, okay, we are mapping the sequence of operation of the movement also can. Okay. Okay, what are the methods there? What are the methods that you have? You're already familiar.
Pareto?
Pareto. Okay, Pareto is listed there. Okay, even Pareto we can use it there. So in what way that we can use Pareto here in defined phase? Remember, we are selecting projects. We are selecting problem. So Pareto can be used. Any idea, please? I need your participation. Need your participation. How? Okay, Zuhair. Okay, how Pareto can be useful in design in defined phase?
We can use Pareto analysis to uh, to to know the number of defects for in a production.
Okay, we know that Pareto is priority method, prioritize. So we can use this Pareto to select the problem. Okay, problem selection. Remember that Pareto, we have something like this. In Pareto, you have studied this before. Okay, the highest number on the left, the smaller on the right. Okay, moving on and so on. So we give priority to the most problematic problem. Okay, so remember that we are doing selection. Okay, so we can select which problem to focus. Okay, project selection. Okay, before we start the define, is also we need to do project selection. So Pareto can be useful in defining which particular problem is to be our focus. Okay, so we also have methods like Kano analysis. Yeah, Kano. This is where we want to understand the voice of customer. Okay, what actually the customer wants. So that defined stage is basically understanding the problem. Okay, what we are having. Okay, what are the scope that we want to focus for project. Remember that in defined stage, we are trying to produce project charter. Okay, there are, okay, we mentioned here project charter. Affinity diagram is another techniques that is used in understanding the problem. Okay, we will see later on affinity diagram. Okay, this is example of CPOC. Okay, CPOC, what we have here is we have supplier, we have input, we have process, we have output, and we have customer. Okay. So by putting this into a mapping, we have a better understanding. Okay, especially in this part, the process. We have the input. Okay, we have the output. Okay. So the input go to the process, produce output. The output will be sold to customer. Okay. Of course, the input here must come from supplier. Okay, very simple. You have supplier providing the raw material, the input, and then the process is happening there. And then it will produce the output, and then you have customer. So in defined stage, we produce CPOC mapping. Okay. So we also can use value stream mapping. Okay, value stream mapping. A process map or value stream mapping may also be prepared. Okay. So this should be completed by at least end of measure step. Okay, some of the tool might be overlapping. We can see in defined stage, we can see again in analyze stage and so on. Okay, this is another example of process mapping. See, this is process flow. You learn this process flow. Okay, I asked you to do a process flow. Okay, you can see now when you have a problem, you can come up with a process flow. You can also have a CPOC diagram. A CPOC diagram is showing more structured. You have the process in the middle, input on the left, output on the right. So extension of output will be customer. Okay, before you get input, you have the supplier. Okay, some people also do like this, the mapping based on process 1, process 2, process 3. Okay, So what is important is we want to understand, okay, about the current process that is being practiced. Okay, so the toll gate is for us for checking before we move to the next stage, which is after D, it is M. Okay, after define is measure. Okay, these are toll gate like a question that we need to answer. Does the problem statement focus on symptom? Are the key stakeholder identified? What evidence is there to confirm the opportunity? Okay, as report diagram or higher level process map being completed, okay, and so on. Okay, remember this, we have toll gate here. Okay, this is the toll gate before you move on to the next process. Okay, like you go to a place which are gated before you are allowed to enter there. So you have a gate. Okay, the checkpoint before move to the next one. Okay. Toll gate, and then the next step is measure. Okay, measure step. Okay, to evaluate and determine the process state. Okay, to identify the key process input variable, key process output variable. Okay, so again, we can use the technique that you have learned in 7 basic SPC tools. Okay, like Pareto chart can be used. Scatter diagram. Remember this measure, when it's started to measure, we collect the data, we put it graphically for easy understanding. You can put in terms of histogram, box plot, okay? And also concern here is measurement system capability, okay? So this is related to calibration, okay? Calibration. What is calibration? Okay, we want to measure the measurement system capability. We need to do the calibration, for example. Okay, anyone know what is calibration? Okay, Iza, what is calibration? Hello?
Comparison measurement.
Okay, calibration is we compare standard with the equipment lah. Okay, so we make comparison between standard with our equipment. We want to see whether our equipment is giving the correct answer or not. Okay, so in calibration normally we compare it with standard. Okay, for example, you are measuring using micrometer. Okay, a simple device. We compare the measurement given by micrometer with standard. Is it 1 cm or 1 mm or 1 cm given by micrometer is the same as the expected unit, okay, 1 cm of the standard. Okay, if you go to metrology lab, for example, there is we call it slip gauges. Okay, these are standard. Okay, we make comparison, what is given by the equipment compared to the standard value. Okay, you need to do calibrations. If you don't do calibration, you may get the reading, but the reading is wrong. Because why? It has not been calibrated. Okay, if you are doing experiment in the lab, you can ask the technician whether this equipment has been calibrated or not. If it's calibrated, meaning that the value given by the equipment is correct. Okay, can be trusted. Sometimes we measure, but we're not sure whether this is correct or wrong. Okay, calibration is very important in measurement. Even if you go to pasar malam, the night market, for example, you buy a chicken, okay, 1 kg. Okay, how sure you are this is 1 kg is correct? Okay, so that measuring devices has to be calibrated. Who's doing the calibration? Okay, in Malaysia, we have agency like SIRIM, okay, or the authorized agent, okay, that has been endorsed by CRM will do this calibration of equipment. If we are using 1 kg, but actually is giving the real weight is 0.9, so this is not correct. Okay, but as customer, we thought it's correct. Okay, if you go and measure with another scale, you may not get 1 kg, maybe 0.85. But you saw it at the night market is showing 1 kg. So meaning that that device is not correct. Okay, so how to do the correction must do through calibration. Okay, so this is important during measure phase. Okay, measure phase. We do the calibration, we do the you know, all these measured data will be plotted into graphical method. Okay, so okay, measurement start with data collection. Okay, and then you can plot as shown here, and even we analyze, okay, the process capability. Okay, we can have a Pareto here, we can have histogram, we can have scatter plot. Okay, and also there is a tool gate for it, measure tool gates. What we check, okay, before we move to the improvement stage. Okay, improvement stage. Okay, analyze stage. Okay, we have D, M, A. A is analyze. Okay, analyze stage. Okay, we take 10-minute breaks before I move on to the rest of the method of Six Sigma. Boleh?
Boleh tak?
All right. So we have a break now. Analyze. Okay, so you nampak benda yang sama ke yang saya tengok macam ni? What do you see on the screen? I just want to confirm.
The analyze step.
Okay, the analyze step. Okay, bagus. Okay, so the analyze step. Okay, in the analyze step. So we have we need to determine. Okay, for example, cause and effect relationship. Okay, cause and effect. So we analyze what are the causes of the problem. Okay, we have seen you can use fishbone diagram, for example. We are analyzing the source of variability. Okay, so the tools that can be used is like control chart. The control chart also can be used in control phase, but in analyze also can be used. Okay, so it can be used at different stages. We can use regression. We can use FMEA. Okay, FMEA, failure mode and effect analysis. Okay, we can use also simulation. Okay, so in analyze, the data will be analyzed to determine is there any root cause for the problem, for the poor performance of quality. Okay, so we can use prioritize techniques like Pareto diagram. Okay, so these are the tools during analysis. You can use FMEA, you can use Pareto, you can use cause and effect diagram. Okay, so of course FMEA is very useful if you want to understand possibility of failure or safety effects that might be dangerous. Okay, but in this case, if we are looking for quality, we might look at the failure effects. a possible failure for the process or for the system. Okay, when it is when we design, we analyze FMEA before we proceed with the production. Okay, so FMEA is one of the techniques that can be used. So we will use, for example, the analysis in terms of RPN. Okay, RPN is the scoring for FMEA. Okay, where we have the RPN is the value where we can get it. We analyze the severity if there is a failure happening. Okay, the severity we multiply with the probability of that failure to occur. Okay, the occurrence, is it frequent or is it rarely? Okay, we will give some scoring there. And also, is there a method to detect the detection? Is there any mechanism to detect the failure from happening? Okay, the failure can cause quality problem, okay, reliability problem, and so on. So all this will be expressed in terms of RPN, or what we call it risk priority number. Okay, the scoring will be given between 0 to 10. Okay, for example, how severe if the failure happened. Okay, so if severe, we give it higher rating. Occurrence, is it frequent, is it rarely, or is it seldom? Okay, so there is a guideline for giving the scoring. Detection, are we able to detect or not? Okay, so if we are not able to detect, okay, the value will be higher. If we are able to detect, the value will be lower. So higher RPN will be given priority in the solution, because we may have many possible root cause for the failure. Okay, so this is just more detailed explanation how we can do root cause analysis. Okay, we categorize the causes like we use fishbone diagram. We categorize into man, machine, okay, material, and so on. Okay, we brainstorm to get ideas. Okay, and we of course select the most problematic for focus because we not possible for us to solve problem at one go. So the root cause analysis tools can be fishbone or root cause diagram, cause and effect diagram. Can be also, again, Pareto is very useful to prioritize. Or we can use the diagram, right? 5Y, 5Ys, 5Y. 5Y here referring to Y. Okay, we are referring to Y. Who? Okay, we're asking this question when we do analysis. When, what, where. Okay, so this is 5Y. Okay, or sometimes you can add one more, 1H. Okay, how the problem happened. Okay, so these are analysis tools, and then we may need to validate the root cause by maybe conducting experiment. Okay, we may run design of experiment. We may plot regression analysis. Okay, to ensure that this is a correct root cause. Okay, so then also again the tool gates for the analysis. Okay, what opportunity are we going to be targeted? Okay, what data analysis support for investigating the target? Okay, and so on. Okay, moving to the improve phase. Okay, in DMIAC. Okay, now we are at the improve. We analyze, now we want to improve. Okay, one of the techniques that is popularly used for improvement is, okay, process redesign, okay, mistake proving, or we can use design of experiment. This mistake proving is like we in the process, we try to prevent from mistake from happening. Okay, you can Google what is known as Pokayoke. Okay, in design, this is very useful. We design to prevent failure from happening. Because if we don't analyze, failure may happen, but if we don't prevent, so it means that during design, is already the fault in the design. Okay, mistake proving is one of method for improvement. Okay, from defect from happening, mistake from happening. Okay, so design experiment. Okay, design experiment. This can be used during product design and also process design. Okay, we may have to run pilot tests. Okay, pilot testing to see whether we got the optimum value or not. Okay. So okay, so these are the steps. Okay, typical step for process improvement. Okay, we describe the process and break into sub-process. So when the process or the problem is big, we break into sub-problem. Okay, we break into sub-problem because solving the whole problem as one, it will be very difficult to analyze, to collect data, and so on. So we may divide into sub-categories, sub-processes. Okay, let's say you have one machine to analyze what is the problem causing the quality. Okay, you will break down the machine maybe from looking at the table that's supporting the workpiece. Maybe you are looking at the cutting point, or you may be looking at the control mechanism. Okay, so we break down into sub areas so that we are more focused in solving that. Okay, so in order to improve, we also need to use that measuring instrument, measurement instrument, variability. Is there any issue of the data collection itself? Okay, identify major component of variation. Okay, and then of course optimize the processes. We can use design of experiment. Okay, so maybe at this stage you maybe not familiar what is design experiment. So there is another course that is teaching design of experiment. Okay, which is where we use the optimization. We optimize the process parameter, and we also optimize product design, okay, and also process design. Optimize the process. Okay. So by looking at the critical variables, okay, what is the best setting when we are running the process, for example. Okay. So these are what to call it, some of the tools that can be used, as we have discussed. Generate improvement idea. It can be from design of experiment. Okay, it can be from FMEA and so on. Okay, as mentioned earlier, affinity diagram. Okay, affinity diagram also can be used, especially when we generate ideas. So if you see here, in affinity diagram, we are grouping this. Okay, this is the skill, this is related to knowledge, this is the tool availability, this is the work environment, work climate. So what is affinity diagram? Affinity diagram is a method, take a large number of ideas and find common theme. Okay, meaning that we are grouping the ideas into common theme. Tema yang mana? Okay, this is just common. So everybody will have ideas. So if we don't arrange the idea into similarity of term of category, very difficult for us to implement that. Okay, so like in the past, people using this sticky note. Okay, sticky note, the yellow notes. You put the ideas and put it on the wall. After that, we rearrange according to similarity. If related to skill, okay, we put this, for example, related to skill, we group it into skill. Related to workers, knowledge, okay, we group it into another group and so on. Okay, the team will use this type of diagram to overcome the paralysis, which is brought on by overwhelming array of options, lack of consensus. Okay, when we have so many ideas, we don't grouping into similarity, so we might be lost in the volume of the information that we have. Okay, we have no way how to start implementing this idea. Okay, how to solve this? We use affinity diagram. What is affinity diagram? Okay, we grouping similarity into a group. Okay, so that this what we call overwhelming, meaning that too much information that we have, we narrow down into similarity, and perhaps we can see what are common. Okay, maybe the different language is used when people are giving ideas through brainstorming. Okay, so normally this affinity diagram is being used together with sticky note in the past lah, but now we have electronics. You can just put it like using sharing. That the same using cloud system and so on. But in the past, sticky note was used because it's physical. So ranking and selecting the solution, when we have many alternative solution, we need to select by practicing the ranking, how to rank. Okay. Okay, objective is to implement very best idea. Okay, many ideas we can get from members. So after that, we may take voting, or we try to get consensus which idea to implement. Okay. Okay, so these are tool gates for improve. Okay, so what we have to check, tool gates like the checkpoint lah, whether we have adequate documentation. Okay, documentation or alternative solution. Okay, complete result of the pilot test, including data display, analysis, experiment, and simulation. Okay, plan to implement the pilot test on the full-scale basis. Okay, maybe initially we start with lab scale, but later on we want to implement it in the real life, in the shop floor, in the company. Okay, so what is our plan? Okay, whether it can be implemented as full scale or not. This should include dealing with regulatory requirement. Sometimes when we want to implement new ideas, okay, there are rules and regulations that we have to follow. For example, OSHA. OSHA is related to safety and health, safety and health regulation. This safety and health. In the workplace, we have to follow safety and health requirement. Okay, especially now we have COVID. There are SOP for dealing with COVID. So when we want to implement new ideas, we have to check whether it clash or not with this guideline, this legal requirement, and so on.
Sir, is there any difference between OSHA and OSHA?
OSHA, how to spell OSHA?
OSHE.
I think this is related to environment. If I'm not mistaken, this is environment. Occupational safety and health and environment. Okay, because A here is act. This is act, ACTA. Okay, occupational safety, health, and environment. Because now, not only safety and health, but also environment is a new, not new lah, but it's becoming more important nowadays. When we do anything, we need also to look at the environment in terms of carbon emission, in terms of pollution, how we dispose waste materials. Okay, so occupation, O is occupational, occupational safety. Okay, so some industrial engineering graduate, they work in implementation, enforcement officer, for example, for Department of Health, DOSH. In Malaysia, we have DOSH, Jabatan Kesihatan dan Keselamatan. They're doing inspection in the workplace, in factory, in construction site, okay, Department of Occupational Safety and Health. Okay, so now not only safety and health, but also environment. How people, for example, dispose chemicals. Okay, so this is under this related lah under Department of Safety and Health, because when there are more factories, more industries, environment is getting polluted. Okay, the river is polluted, the air is polluted, the land is polluted. So how people dispose the waste material? Many process involve chemicals. So they need to handle this properly. Treatment has to be done before it's disposed. Okay, so the control stage is the last one, the control on DMIAC. Okay, so this is the last step. So normally we implement control charting. Okay, so once we implement the improvement, we need to control the improvement, to maintain the improvement so that the improvement achieve the intended target, and also for continuous improvement. Okay, complete all remaining work on the project and provide process owner with process control plan. Okay, so we may also involve training. Okay, so when we introduce a new process, for example, a new method for improvement, we need to train the workers how to maintain and to implement the new process. Okay, so control step also involve training, and also method and metric for future audits. Okay, so we need to also come up with how to measure and to maintain the performance, okay, so that it is at least at the same or better, not getting worse. Okay, control phase is what are the tools? Okay, basically control phase is to sustain the Six Sigma initiative. Okay, so the tools are control chart. Okay, pre-control chart and run chart and so on. So we will study this control chart. This is control chart where we have, I did mention earlier, we have upper control limit, lower control limit. Okay, and then we are plotting our measured data, whether it is within control limit or not. Okay, so for example, we are monitoring the quality for surface roughness. Okay, we want to make sure that it is within the limits. So this is what we call it, to sustain, okay, whatever initiative that we have taken, whether it is getting better or if it is showing the opposite direction, getting worse, we need to again look at the root cause and keep introducing, okay, maybe identifying the problem or the root cause that we have maybe overlooked in the previous phase. Okay, so upon doing this, we have 5 steps there. We complete the wheel here: define, measure, analyze. It looks simple, but when we implement it, it's quite challenging. But this is giving just general guideline. So I think when we do your group projects, you may implement some of these methods. Okay, it will be look clearer. Okay, so and in the control phase, you may come up with standards. Okay, standard or procedures. Okay, to maintain, to sustain, okay, the improvement that we have gained. Okay, what are procedure and standard? So if we don't document that, the problem is if a new staff coming, we do not know. He doesn't know, okay, how to operate in a better method that we have come up as a solution. Okay, we need to come up with new procedure, SOP. Okay, what are the standard? Standard here referring to standard procedure. It could be standard for implementation of process. Okay, so standard is where we compare, okay, the unknown with the process. Okay, if you have problem, for example, a problem is coming, cutting tool has broken, what are the standard? Okay, what are our standard in terms of replacing the tooling? Okay, how we monitor the performance of tooling? So we must have a standard. Okay, so procedure and standard we put in detail, and then they serve as a reference for every workers lah. Okay, so either is for getting understanding or as guideline in doing the activities. Okay, procedure also can be used for training for the new staff. Okay, so many benefit of having standards lah. Okay, many benefits. Okay, so it will avoid any conflicts, any contradiction in terms of solving the problem. So we also avoid from repeating similar problem. For example, when we have standard. Okay, okay, this is planned for holding the gains. Yes, when you gain the benefit, gain the benefit of Six Sigma projects. So we need to maintain that using standard and procedures. Okay, come up with standard procedure to maintain the same gain. Gain here meaning that whatever you have benefited maybe improve in terms of reduce defect. Okay, how to maintain the reduction in defects. Okay, by having standard. Everybody follow the standard. Okay, so process control. Okay, related to control also. Okay, we can implement again SPC control chart. Can implement. As I mentioned earlier, mistake proving method also can be used here. This is to prevent failure from happening. Okay, example of control chart. They also have toll gate. Okay, we check what are the things that need to make sure before we go to the control phase. Okay. All right. So in summary, we can have that defined phase. We have project charter. We have to understand the customer. Okay. We do also is what we call it process mapping. Process mapping that we have CPOC. Okay. So project charter is where is like a project proposal. We have that document. So in measure phase, we concern about data collection. We concern about calibration of the measuring instrument. Also, sometimes we refer here MSA, measurement system analysis. Okay, where we ensure that the measuring tools are reliable. Okay, for the analysis, okay, we are implementing data collection, and now we have to analyze, okay, to see the root cause. Okay, root cause analysis, okay, process analysis, data analysis. For improve phase, okay, so we can implement here like design of experiment. Okay, one of the method, process improvement. Control phase, okay, you can use control chart here. So basically, the tools that can be used in DMIC, the tool that you have learned, the basic SPC tools, and there are tools that you will learn, for example, DOE. It can be implemented for improvement, for optimization. Okay, so in summary here, we can say also that DMIC is okay. What happened to this? Okay, DMIC is define what is important. Okay, we define what is important. So we see, okay, measure how we are doing. We want to know currently where we are. Okay, before we move forward and improve, we need to see how we are doing now. Okay, so we measure the process and determine the current performance. Okay, this is concept of measure. After that, we analyze what actually went wrong. What is wrong? Okay, determine the root cause. Improve is what need to be improved. Okay, improve the process, or we find a way to eliminate the root cause. And when we say control, we are concerned about how to maintain the gain. How do we guarantee the performance? Okay, control the improved process performance to ensure sustainable gain results. Okay, any question up to this point? Hello? Are you listening or not? Okay, Jacob. Hello, Jacob.
Yes, doctor.
Okay, what do we do at control phase? What do we do in control phase? Hello? Listen to me.
We maintain, we do control chart.
Okay. Okay, in control phase is for us to maintain the gain, whatever improvement that we have achieved. Okay, so one of the techniques is we use control chart. Okay, so in summary, we have here Six Sigma is define, measure, analyze, improve, and control. Okay, it looks very simple, but implementation is not as simple as we see, because first we have to define the problem, select the problem. Okay, we can use Pareto there, and then we need to measure the current state of the situation, where we are now, and then analyze, okay, to identify the root cause of the problem. Okay, we can use FMEA. What is FMEA? Jacob, what is FMEA? Okay, anyone please? Afifa, what is FMEA? Yeah.
Failure mode and effect analysis.
Failure mode and effect analysis. So
And
where do you use
yes.
FMEA? Where do we use FMEA?
Analyze.
Analyze. Okay, in FMEA, I did mention that you have RPN. What is that RPN?
Risk priority number.
Risk priority number, okay? So this is where we try to predict potential failure before it happens, okay? Whether the occurrence, is it frequent? And then if it happened, is it severe or not? Okay, do we have mechanism to detect the failure? Okay, so this can be used during analyze. Okay, so we see that EMIAC is actually a collection of various tools that can be used if we want to solve a problem. So it has been proven effective. Okay, many companies have implemented it. Okay, Motorola was the pioneer in Six Sigma. Okay, so Motorola, and then later on GE, and many other companies have implemented this. Okay, okay. So as I stated earlier, if you are going for certification, okay, certification, maybe if you are interested later on after you graduate, you may get certified, okay, certified Six Sigma expert. So maybe you can start with a yellow belt. Okay, this is the what do you call it, the category that they use. Yellow belt is aware of Six Sigma principle. Okay, just create awareness. Green belt, use analysis tool and DMAIC for Lean Six Sigma. Okay, focus on Lean principle. Okay, and then you move out the black belt. Okay, full-time project leader. Okay, so you are dealing with projects for Six Sigma project, okay, in the company. Training others, Okay, assisting others for project implementation, or even you can go higher, master black belt. Okay, where you are more on consulting, advice on Six Sigma, black belt with at least 2 years experience and so on. Okay, so this is what is being practiced in the industry. People are getting certification on Six Sigma. Okay, so if you already have background, like you take this course, when you take certification, will be easier because at least you already know some of the tools. And okay, as in the previous class, I say that I did mention that now the integration between Lean and Six Sigma. Lean, what is Lean? Okay, let me ask. Okay, Julian, what is Lean? Julian?
Yes, doctor.
Okay, what is Lean? We have Lean Six Sigma. Okay, now we have Lean Six Sigma. We have Six Sigma. Okay, before you answer the Lean, what is Six Sigma? What is the target for Six Sigma method? Anyone can help? I mentioned this in the last class, last week. Lean has a purpose and also Six Sigma also have a purpose. Both are now combined. People call it Lean Six Sigma. Okay, Lean Six Sigma. Okay, Six Sigma is talking about what?
Process improvement.
Okay, process improvement. This is variation reduction. Okay, we want to reduce variation. Or even we can say eliminate the variation, but sometimes not possible. So this is like you are from this. Okay, you want to reduce it. Okay, oops, sorry, sensitive, this one. Okay, if you are like this, so now you want it to reduce the variation. Okay, to make it okay slim lah. Okay, not very fat like this. Okay, this is Six Sigma to reduce the variation. Lean is reduce waste. Okay, Lean is reduce the waste. What are the waste? Can you give example of waste?
Transportation waste.
Okay, transportation waste, inventory,
Defects.
waiting. Okay, what else?
Defects.
Time waste.
Overproduction.
Defects. Okay, so waste elimination. Okay, waste elimination, eliminate. Okay, so Six Sigma is variation. Okay, process variation reduction. We reduce, here is reduce the waste, here is reduce variation. Okay, so that's the key. The key, we need to reduce the variation. If possible, we want to produce on target, if possible. But here we don't want to reduce to have a waste. So basically, customer satisfaction when you have low variation, higher quality products. Here is more on having speed, okay, having good flow when you have low waiting. So Six Sigma quality support lean speed. Less rework mean faster cycle time. Okay, so they go together. All right. Any question?
So
Okay.
far, no, doctor.
No question. Okay.
Noted.
So, okay, the next class I will go on control chart. Control chart. I will cover on control chart for control phase. Okay, control phase. We will start with attribute control chart, P chart, and P chart, and so on. All right. So before we end for this class, okay, can somebody help us to summarize what is actually DMAIC? Okay, can I have here Nada? Nada, is it Nada? Eliana? Are you there? Nada, Eliana? Yes, you are there, but your mic is not.
Yes, doctor.
Yeah, Nada, Eliana. What is DMAIC? You know or not? Okay, what do we do at D? Define phase. Okay, let me call another one. Lim Jin Yang. Lim.
Yes, doctor.
Okay, what do we do at define phase?
Define the problem or the requirement from the customer.
Okay. What document we produce in define phase? Project charter, right?
Yes, yes.
What is project charter?
And to list out the
What information do we have on project charter?
problem.
Okay. Okay, in project charter, we spell out, okay, the problem, the scope of the problem, the objective, who will be responsible. Okay, this is like when you do a proposal for projects. So the define phase is defining the problem. You do selection of problem because in organization, there will be many problems. So you need to prioritize. How do we prioritize which projects that we should focus for Six Sigma project implementation? How do we select a project? Okay, Muhammad Fitri. Fitri?
Fikri ke Fitri, doctor?
Mana-mana satu lah. Fitri pun ada ni, Fikri pun ada ni.
Oh, ya ke? Apa dia doktor tadi? Macam mana kita
Select.
Okay. Tadi kita ada dekat project charter kita ada guna 5W.
Okay.
Why, who, what, when, where.
Itu masa selection ke?
Yup. Bukan doktor.
Okay, siapa boleh bantu? How do we select? How do we select a project for Six Sigma project? You may have a lot of problem in company. How we select to make it as a Six Sigma project? Okay, I call. Okay.
Maybe SIPO, process mapping, Pareto analysis.
Okay. What is
Affinity.
What is the use of SIPOC? What is SIPOC, Erin?
SIPOC is where is it? The S is
Okay, you just remember in the middle is there is a process. Before a process, there will input. After process, there will output.
supplier, input, process, output, and customers.
Okay, very good. Okay, you just remember. If you cannot remember that SIPOC, just remember that there is a process. Before a process, there will be input. Okay, after a process, there will be output. Where the output goes, output go to customer. Okay, where the input is coming, the input is coming from supplier. Okay, so this SIPOC. So what is SIPOC there? What is the purpose of SIPOC? SIPOC. Which stage that we prepare SIPOC?
The define step?
Yes, define step. Okay, we are defining the problem. Okay, so by putting that in terms of mapping, so we know that where are potential problem. Okay, beside using SIPOC, is there any other method that we can use to document the current process? Okay, Fatimatul Wafa. Okay, Fatimatul. Besides SIPOC, is there any other method for defining?
I'm not sure about the method because at first I go to the toilet for the define and verify.
You're not sure, okay. Okay, Faisal? Faisal Delhi Al-Fawaz. Is there any other method besides SIPOC for defining the process or for defining problem for Six Sigma project? Okay, anyone, please volunteer. Okay, Abdul Rahman. Alamudi. Abdul Rahman.
Doctor, is it priority chart?
Not exactly. What are other methods for us to understand or define the problem?
A flowchart?
Yes.
A process?
Yes, flowchart. Okay, you have learned
Yeah.
flowchart. Flowchart, what else? We have SIPOC, we have flowchart. Any other thing?
Pareto analysis.
Carnot analysis.
Okay.
Pareto?
What?
Pareto?
Pareto is for selection. For selection. Okay, for understanding of process, okay, we use SIPOC. So for the next class, I would like everyone, you go and Google example of SIPOC. Can just Google example of SIPOC. There are a lot of examples on internet. Just find one and try to understand how to prepare a SIPOC. Okay, where it's having supplier, okay, input, process, output, and customer. Can or not? For the next class.
Can, Doctor.
Okay, I will ask you to share in the class and I will also open a submission in e-learning. Okay, you just go and Google one example of SIPOC. Make sure you understand whatever you select, example there, and then upload to e-learning and I will ask a few example that you need to share in class. Okay, be prepared to share this class for the next class. Right, if there is no other thing, that's all. So today, roughly, I've explained the concept of Six Sigma as numerical values to describe the quality level, and also Six Sigma as problem-solving methodology. It's a step-by-step methodology for problem solving. Okay, so as philosophy, it is to satisfy customer. Okay, we address the customer expectation. Okay, so Six Sigma can be explained in terms of statistical values. Okay, 2 defects per billion, or if it is shifted by 1.5 sigma, we say that it is quality level at 2 defects per million. Okay, so almost 0 defect. Okay, we target for 0 defect. So this Six Sigma becoming more important now when the industrial revolution come in. Here we have Industry 4.0. Okay, actually 4.0 is actually make the Six Sigma faster and better to achieve the target. Okay, having the Industry 4.0. I mean, yes, the technology in Industry 4.0, the data analytics. If you see that Six Sigma is data-driven methodology, everything is related to data. Data about the process, data about the quality, data about control. Okay, Industry 4.0 is also related to data. Okay, we have big data, we have IoT, all these are collecting data. So Industry 4.0 and Six Sigma can go together to boost the competitiveness in organization. All right, I stop here, and don't forget that you need to find one example of CPOC, okay, and then upload to e-learning. I will randomly ask any of you to share in the class for the next class. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.